So this is the implementation of Team Whiskey's criminal database. We're going to be stepping through the scenarios given to us to showcase this program and its features. The first scenario has us tasked with assuming the role of Detective EMD Pick. We're going to log in. Using some of the features from Account, we can log in with a username that we've determined to be Pick official, and their password is 123. So we've logged in and we're greeted with a personalized welcome message with our name. It's a nice touch. We can go ahead and start entering the information for the case. The name of the case will be robbery at gunpoint. A brief description is what we have is white teenaged male at the GameStop. And what they've stolen is a gaming console and 20 games. The address of this particular GameStop is given to us. It's at 1725 Robinson Boulevard. Occurred on March 3rd, 2021, in between 7 and 8. So we're greeted with a nice confirmation message to make sure everything we put in is correct. We're going to go ahead and say yes to that because I think it's good. So now we're greeted with confirmation saying that we've made a successful crime with a randomly generated ID for a crime. And now we can start to put in information for our crime that pertains to what we want to put in. So we are given a suspect info. Let's go ahead and add suspect. We don't know their name, so we're going to go ahead and put in the name as unknown suspect for now. Their height was approximately 5'9". He was a male, they know they're white, and they were a teenaged boy. We know that they were in a gray hoodie, has shoulder length hair, and has blue eyes. We can confirm again, make sure we're correct, and we can go ahead and put it in. We're also given a witness who was actually the store owner, so we can go ahead and add the witness in. The witness's name was Clement. We don't have an ID for them, so we're going to just put in a generic ID for them. We'll just call it that one. They were a male, they were white. Their phone number is given to us, however, so we have 803 898 7666, and then their age is 21. Their statement said, we go and copy paste this information. So we can, again, once again, confirm the information. We're not given a lot of information about the victims since there was no person that had been murdered and there was not a lot of evidence given to us. So we can go ahead and finish this information and just go ahead and finish it in this case. So now the case info was saved, and we can check to make sure it is by checking view cases, and we can see that it is indeed pushed into there. Let's go ahead and run through the third scenario where our boss has assigned us to work on a new case ID. In this case, our case ID is going to be 4646, since that should be the case ID of one of the records in our sample data. So we're going to go ahead and go to search cases, and we're going to enter our case ID is 4646. And it says that we've pulled up this case called Homicide at City Hall with the case ID, the description, the address, the date, and time. We're given a couple options here with our information, so we can view victims. And we're given this list of victims, and unfortunately there's only one, Randy and Val. We press enter to go back. Once we've seen all the information it provides us, the gender, height, age, race, phone number, and the deceased case for true. We can also view the current suspects. We have two suspects for this particular case. We have one here with information and one here with the following information as well. We can also view the witnesses. And the witnesses here again are previously like Henry Claimant, where they have the name, gender, height, age, race, a phone, and a statement. And if you were to do these statements, they are pertaining to the case. And then we can also view evidences where we have certain evidence that was found at the scene of the crime.
Alright, so the single most important part of our UML diagram is the crime database class. This class is the backbone of our program, and it is where most of the core functionality is handled. So within our variables, you can see we have a scanner, we have users, witnesses, victims, and basically sets of all of the different class objects that we have throughout our program. Now here, obviously, we have the empty crime database constructor. We also have get field, get numeric field, and get boolean field. Each has a prompt, and we use each of these methods to gain user input in various forms. We also have the sign-in method right here. We have the method which takes in a number of different variables with information about the user that they can use to create their account. We can create suspects, victims, witnesses. We have methods here for creating pretty much any other kind of class object. Finally, we have a random ID generator for generating information about our users. We create new accounts. We can enter information about suspects, witnesses, victims, and crimes. We have the corresponding display methods. And finally, we have a method for getting all of the instances currently in play and for displaying the current case by the ID. Here we have our crime class, which includes variables for string name, string description, string address, string time, and finally, an integer for the crime ID. Now here we have the constructor, which passes in all 5 instance variables, and obviously we have the accessor and mutator methods for each variable. We also have the ArrayList set of crimes down here, including the getInstance method, the crime accessor, the addCrime method, and finally our saveCrimes method. Here we have the crime database UI or user interface, which is essentially what the user interacts with when they use our program. You see here we have a welcome message in the form of a string, and we have a sequence of strings for our guest menu options and main menu options. We also include a scanner and our instantiated crime database. Here is our empty constructor for the crime database UI, and our run method, which will obviously initiate the program. Here we have our initialize UI method, and we have our display methods for the guest and main menu. Finally, we have a method here called getUserCommand, and our main method. Now, for our evidence class, we have 3 main instance variables. We have the string name, string description, and integer case ID. Now here you see we do have the constructor, which passes in those 3 variables, and we have the accessor and mutator methods for all the variables present. Finally, we also have the evidences class, which is essentially an array list of evidence, and basically contains the set of all evidence class objects in our program. We have the getInstance, getEvidence, and finally we can add new evidence to the array list. And of course, we can save all the current evidences. Here we have our user class, which includes an integer ID, string first name, string last name, string username, string email, string password, and string type. Now we have the user constructor, which passes in all of these instance variables, and we have the accessor and mutator methods for each instance variable. Pretty simple. And also here we have the ArrayList set of all users, which once again includes getInstance, getUsers, a boolean to determine whether the user is currently existing, an addAccount method, and finally our save method.
Okay, so I'm going to talk about the data constants part in our UML diagram. So, in data constants, it has protected users files and like first name, last name, stuff like that. And it also has those files for crime, suspect, witness, victim, evidence, and record. So yeah, those are the data constants, and data loader and data writer both extend from data constants. So the data loader class loads all of the users, suspects, witnesses, evidence, victims, and crimes, whereas the data writer gets the users, suspects, witnesses, victims, evidence, and their JSONs, and also saves those, like saves the suspects, witnesses, like crimes and all that. So yeah, that's like the data constants and the classes that extend from it. And I also want to talk about the person class right here. So the person class has the person's name, height, gender, race, age, and ID. And these 3 classes, suspect, witness, and victim, they all extend from person, and they also have like the suspect's name, height, gender, race, ID, and all that. then so do victim and witness. So yeah, those extend from there, and these classes, suspects, witnesses, and victims, they all hold information from their said class. So like suspects holds information from suspect, witnesses holds information from witness, and victim holds information from victim. So yeah, and then yeah, that's the person classes and the classes that extend from it.
So yes, the actual design pattern that we decided to implement for this project was a singleton design patterns because we found it most beneficial to have a bunch of these objects working and interacting with each other in one single class. One, to maintain a streamlined process, and two, we wouldn't have to worry about constructing different decorating classes or different interfaces. I think the biggest takeaway is sort of how we are actually getting and retrieving information and how all of the objects are interacting with one another. When we want to enter in a new information, we're actually going to be passing in the crime identification number. We get the fields from the user, but then we always set the ID to be the same as the case we're setting the information to. That way, when we call upon them, when we want to display information, we're just using the ID that we passed in. We're using the ID of the crime to get the evidence. So, for example, just looking through our evidence list, if our evidence list ID is equal to the ID that's passed in the parameter, which in this case is crime ID, then it's just going to get all the information that we need.